Now, the most common curve that we want to parameterize is probably just the simple line segment. So here we are in the XY plane. I'm going to draw everything in the positive quadrant, but there's no reason that it has to be. And I'll draw a line segment between 2 points, here and here. And this starting point will be x0, y0. The ending point will be x1, y1. And we can go ahead and label the axes as well. This is the x-coordinate for x1, y1. This would be the y-coordinate for x1, y1. And then here is our x0. Here is our y0. And the way we're parameterizing this is where we want to have t is equal to 0 be the starting point, and t is equal to 1 be the ending point. And here's the way that we do it. Here's the formula that we apply. We'll let x be equal to x0 plus quantity x1 minus x0 t, and we'll do the exact same thing for y, replacing all the x's with y's. And what's going on here? Well, what we want to do is we want to have that when t is equal to 1, we want to plug in and get x1, y1. So we should make sure that that works out, certainly. So let's go over here and do a chart of values, t, x, and y. And sure enough, if I plug in 0 in for x, in for t, then this will cancel out and that will cancel out. So all we're left with is x0 and y0. If we plug in 1, then we get just the t's will go away, like that, leaving us with x0 minus x0, x1, and y0 minus y0, y1. So there's x1 and y1. And of course, if we plug in stuff in between, we should get points in between. And it's easy to see that x0 minus half an x0 would give us half an x0. And then we also have half of an x1. So we get the average of those 2 points. And we get the average of the y values as well when we plug in 1/2. So this would be the point where t is equal to 1/2. And then, of course, a quarter. If we were to plug that in, we'd get this point. 3/4 to give us that point, and all the points in between we get by plugging in values between. And that's the other important part, is that our t value should range between 0 and 1. So that'll be the last piece of information. And no matter what your line segment is, if you're using these formulas, your t values should range between 0 and 1. So now I've got my system of equations. Let's go ahead and work a couple of examples of where we want to parameterize line segments. So for example, give a system of parametric equations for the line segment joining the points 2, -3 and -1, 4. Clean that up a bit. All right. So you can draw the picture. In fact, I'll go ahead and draw the picture just to illustrate things, but there's no reason that you have to. So we've got the points 2, -3 and -1, 4. All right, and so I'll plot those 2 points, 2, -3, -1, 4. There's the line segment that I want. And let's say, so we said that we started with 2, -3, so I will mark that with t is equal to 1, or sorry, t is equal to 0 is where we start. and then t is equal to 1 is where we'll finish. And it's just as simple as applying the formula. All right, so this is my x0, this is my y0, this is my x1, this is my y1. All right, so let's just plug into those formulas up there. So we've got x is equal to x0 is 2 plus quantity x1 minus x0 times t. And then we'll do the same thing for y. Y is equal to y0 is negative 3 plus y1 is 4 minus a negative 3. And then those simplify, of course. So it's going to give me x is equal to 2 minus 3t, and y is equal to negative 3 plus 7t. And sure enough, if you were to plug in values, let's plug in t is equal to 1/2, then my x value would equal 2 minus 3/2, and so that would be 1/2, and then also it would give me that y is equal to negative 3 plus 7/2. That would also be 1/2. So there's that point right here that should be on the line 1/2 comma 1/2 at t is equal to 1/2. So that definitely fits the picture as well. The last thing we need to throw in is because we only want the points between 2, negative 3 and negative 1, 4, we need to not forget to tell those reading that t is ranges only between 0 and 1. And just to illustrate that, what happens if you don't do that? Well, then I could plug in something silly like negative 1. That's not where it's supposed to be. And then what would my x value be? That would be 2 minus a negative 3 would be 5. My y value, it would be negative 3 minus 7 would be negative 10. So we go out 5 and 10, and that's this point way down here that's on the line, but it's not part of the line segment, and that's important. We don't want to include those points right there, so that's why we don't have those. Okay, let's do another problem. All right, this time I want to give two different parametric equations, systems of parametric equations. For the portion of the line y equals 3x minus 2 between x is negative 1 and x is 2. So again, I'm not sure how useful it is, but we could certainly draw a picture if we would like. First, we'll draw the entire line. The entire line, we have a y-intercept of negative 2, slope of 3, so we'll go over 1, go up 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, and then back 1, 2, 3. So here's the entire line right here, sketched out for us really quickly. Okay, but we don't want this entire line. We only want the portion of the line between x is negative 1 and x is 2. So I'll take those, and that would be, here is negative 1, x is negative 1, 0, 1, and 2. All right, so this is the part of the line that I actually care about, is this portion right here. So I want two different systems of parametric equations, and this is basically where I'm just going to use the fact that I have y as a function of x, but I'm also describing a line segment. So I have two options to solve this problem. All right, so the first way I'll do it is considering y as a function of x. The function of x would be that 3x minus 2. All right, so the trick there, if you have y and it's a function of x, all you've got to do is let x is equal to t, and then y would equal, you replace your x with a t, 3t minus 2. Now if you do this method, remember that you have to use the x values, -1 to 2. Those are the x values, and x is the same thing as t, right? So those are the t values. And there is your system of parametric equations. The other option is that, hey, we've got a line segment, and we could go left to right here, or we could go right to left if we prefer. But if we go left to right, that would be the point -1, comma. Let's see, what is that? Well, just plug in -1 into the function. That'd be -3 minus a 2 is -5. Up to 2, comma, plug that into the function. 3 times 2 is 6, minus 2 is 4. All right, so then I've got 2 points. I want the line segment between those 2 points. So we're considering as a line segment. And we'll use the formula. X equals, let's label this stuff, x naught, y naught, x1, y1. So we'll take the x naught, -1, plus x1 minus x0, so 2 minus a -1. We'll go ahead and write that out. T. Same thing with the y. Y naught is -5, plus, let's see here, that's going to be 4 minus a -5, t. So I'll simplify those. That's x is -1 plus 3t, -5 plus 9t. And then remember, if you're ever using this formula, it's always from t is between 0 and 1. And the reason why is that, well, just plug in the number. If you plug in a 0, you get 1, 5, the starting point. If you plug in a 1, you get 1 plus 3 is 2, -5 plus 9 is 4. So there is, once I simplify those, there is my system of equations considering it as a line segment. And remember that you can have 2 different systems of parametric equations that both represent the same line. So we don't need to worry about that. Okay, the last thing I want to mention is what happens if you just drop off these t values. So I'm not going to do a separate example, but I just want to point out, to get the whole line, all you have to do is just let t be any real number. You know, you could write that as t is between any number between -infinity and +infinity, which of course is all of them. And then you could use the same line segment formula. You get the line segment between t is equal to 0, t is equal to 1, but if you let t be any real number, then you're just going to continue on in the same direction. T is equal to 2, t is equal to 3, opposite direction, get t is equal to -1, and you keep going in both directions. And in fact, that's the default, so you could just not mention it at all, and that would be the assumption, is if you don't have any bounds on your t values, then t would range anywhere from -infinity to +infinity. That would get you that entire line.